and water will come out. So what is the happen? The placing of this, you can say cylinder system, if there is a water table up to a, you can say around less than 15 feet, 20 feet, in that range is there. So generally we are using this type of casing here with very close to the pump system. But if water table is going down, then in that case, with the help of this bucket piston, you can say what happens that it creates the vacuum low pressure area below this. That's why water from the bottom enters in this area. So there is some limitation that it cannot create a high level of vacuum, you can say, or high level of low pressure zone. So that's why if such type of scenario is there, we have to keep this cylinder below at certain depth, so that there will be less suction force will be required, and there will be no, you can say, water will not leave this space. Otherwise, with the help of this connecting rod, it will be difficult to take out water for that. So that's why we place this according to the water table. So this was the hand operated. Now let's say you have the mechanical power operated system. So in the mechanical power operated system, like you can say, it may be through the electricity, or maybe diesel engine or any petrol engine. So what happens here? This cylinder is there, and in this cylinder there is a reciprocating motion of the piston. Like in you have studied in the engine, there is a reciprocating motion of this piston. So if it will go in this direction, here in this area the low pressure zone is created. So this suction valve is open, and water from sump will enter into the in this chamber. Then if it will go in this direction, then what happens that this valve will be closed and this valve will be open, and whatsoever water is available in this chamber of this cylinder, that will go out through the delivery pipe. So this is the system. So in this, if a higher speed is there, there will be more discharge. Less speed will be there, less discharge will come. And this type of system, actually generally, as I told, this is the positive displacement pump. So positive displacement pump means we have a very good control over the discharge. So in our day-to-day life, even in petrol pumps, such type of pumps are used. Even to create high pressure, we are using such type of pumps, so that even in the washing of vehicles, you see such type of pumps they are using. The reason is that creates, number one, higher pressure in the delivery side, because in the washing we require, and second, we have very good control over the amount of discharge. We can make the arrange the good suitable mechanism for the measurement of the discharge through these pumps. So, and there are two types of system in this. One is the single acting reciprocating pump, and another is the double. This in the single acting, what happens? Try to see that if it will going in this direction, water will enter here, and it will going, if it is going in this direction, this water will going with the valve, it is going out. So this is the single acting reciprocating pump. And in the both the stroke, if you want the water here, in the, you can say, in the delivery stroke or discharge stroke, you will get the water, but suction stroke, there will be no water in the delivery line. So what happens? The pulsating impact of pulsating water we can get from this pump. So to avoid that, more, if you want more discharge, we have to go for the double acting reciprocating pump. So in the double acting reciprocating pump, what is the scenario? That the in the suction and delivery, both stroke we have the water. In the suction stroke, if it will be there here, what happens? Water will come here, and here whatsoever water was available, that will go out in the delivery line. After that, we can join these two delivery pipes and we can get water. So, and when it will go this side, here there will be suction and here there will be a delivery. So in this way, in double acting means in the both the stroke we can get water, and we have the two delivery pipes in for each strokes, and it will join together. So there will be more uniform amount of discharge you can get in comparison to the single acting reciprocating pump. Now then another type of pump which is comes to our day-to-day life, even if you see in on this earth, all the animals which are having little bit bigger body, in I'm not telling the insect and pest, about the insect and pests, other the things like human beings, animals, everybody has the pump in their body. So even you people having the pump in your body, and that type of pump is the diaphragm pump. So because it is related to your body, and a cardiologist is dealing with that pump. So here you see this diaphragm is taking the shape, and you see what happens, it is going down then going up, and in our heart we have the both side diaphragm. So what happens, it from two sides there is a pressure we are counting. So what happens, if diaphragm go up, then blood or any liquid comes here, then when it is goes down, this valve is closed and this going this side. So this type of pump is there in our body. So that's why I was interested to make you aware that this diaphragm type of pump is utilized in our heart and from both the sides. That's why there are valves, and if the diaphragm working, this diaphragm working is, you can say, reduced. It do not have the muscles energy. Those muscles have the energy, and those muscle energies reduces. So what happens, the doctor are putting the pacemakers. So pacemakers provide the electrical signals to the muscles so that it will perform and regulate the process of this pumping, so our heart will work in better way. So this is the diaphragm pump everybody, every human being is having in their body. Then gear pump is also a type of the positive displacement pump. We can get the regulated discharge and the high pressure discharge with and like the reciprocating pump, if you do not have the double acting, we can get the pulsating amount of the discharge. But here in gear pump, that type of process is not there. We can get the continuous type of discharge, and we can measure the amount of discharge so in better way. So that's why the gear pumps are used in the system. Then we have the vertical turbine pump. Earlier days, when what happens, this is the electrical motor. If this electrical motor, if you want to keep inside the any tube well, what happens, earlier scenario, these pumps, these electrical power prime mover or electrical motor, it is not possible to keep in the inside the well. The reason that at that time or a few years back, you can say, the technology for sealing of the electrical motors are not, you can say, very proper. technology so that we can seal the electrical motor, and if we can keep that electrical motor inside the water, and there will not be any harm to the motor, electrical motor. So this type of vertical turbine pump used, where prime mover is on the top of the well, means above the ground level, and but your pump system is inside the water and it is connected to a rod, and this rod is connected to the electrical motor. So such type of vertical turbine pump was there, and under the condition when there was no proper sealing mechanism, if you are interested to keep the electrical motor inside the water level or below the water. Such type of system was not there. There was much chance that if you keep this motor inside the water, there will be a shortage in the electrical connections, and all those things will happen. So for that, with the development of the technologies, there was the submersible pump has been invented, and in the submersible pump you can see again that there is a prime mover. So this part is the electrical motor, and this is the part of the pump, and in this pump it is connected to the sieve. Here we can water will enter, and this is number of these cups we can increase if we requires more delivery lift. A delivery side lift may be lower or higher depending upon that situation. Where we are keeping this pump, we can increase the delivery height, and we can increase the number of these bows. Number of bows are, if you increase, more delivery depth you can provide, delivery lift you can provide. So accordingly, nowadays, because most of the area, what happens, there is a good utilization of the groundwater. So definitely, and people are giving less emphasis to the groundwater recharge. So what happens, the scenario will be, if less we are adding, withdrawing more water and adding less water. So what happens in the future run, ultimately it will reduce the water level will be going to diminish. You can say there will be decrease in the lowering in the water level table. So you have to lift the water from more depth. So in that case, now people are preferring, because the submersible pump has the capacity to lift the water from greater depth. So that's why nowadays in the because water table is going to down, and in future it is also expected, if the groundwater recharge position will not be better, so it will be still down. So this pump very much suitable, and the earlier people are using much centrifugal pump in the agricultural sector, but nowadays people are shifting from the centrifugal to submersible pump because there is a lowering in the water table. So because there is a limitation that centrifugal pump has the lift, suction lift not more than, you can say 7 to 8 meter, 25 feet, not more than that. So that's why it is this type of pump is preferred, and because it is kept inside the well where water is there, inside the well where water is there, and very good sealing mechanisms are coming, that pumps are working continuously for larger duration, 4 years, 5 years, more than that there is no any problem. So that's why this system is presently people are using. So now we come to the centrifugal pump, and this centrifugal pump, as I told, this is the variable displacement pump. So in here, as I told, there is a need of power to operate the pump. So electric motor is there, and this motor is connected with the shaft, and this shaft transmit the power, and this is the pump here. This part of the pump is called impeller, and this is the casing of the pump. In the casing, there is a only important component is only, you see, only this is the casing. Inside we have kept the impeller, and this impeller is operated with the prime mover. This is the pump set. No any, you can say, very any hard technology is there inside. Only a one thing is there, that is, you can say, this is the impeller. Okay, and this impeller kept in a casing. This is the casing. Okay, and this casing is connected to the suction line, and water will enter here in the eye of the impeller, then it rotates and it will come out through the delivery line. This is the delivery line. This is the system of a very simple system of the centrifugal pump. Just you can see here, and here at this place we are using some boost type of structure, so that there will be whatsoever water will be water will be coming here, that water will not go out here in this direction. So that's why here some sealing through the bush we are providing. So here you see, this is the just cut section of a centrifugal pump. So this is the discharge area in which water is going, and the water is coming through the suction line. This is the suction line, and this is the eye of the impeller. And if this is the impeller, this yellow portion is the impeller. This impeller rotates, and if it rotates, so what happens, that the whatsoever water is coming into the eye of the impeller, that water will go outside due to the centrifugal force. So that's why this is the centrifugal pump. This is called centrifugal pump, and if it will come to the outer edge of the impeller, and then this water will going through the help of the casing, it will going to the discharge line. So this is the principle. Only important component is the impeller, which is connected to the shaft, and this shaft is connected to the prime mover, and which rotates the impeller. And here some sealing arrangement, as I told, we are providing the boost, so that whatsoever water is available in the chamber of this casing of this pump will not go outside, you can say. So this is the system which we are providing. To support the shaft, we are providing the bearings, and these bearings are provided to provide the support to the shaft, and oil rings are there, sealing mechanisms are there. So these things are utilized in the construction of the pump. And as I told, there is a very important component of the pump, a centrifugal pump, is the impeller, which rotates inside the casing. So in this, there are two types of impellers are coming. One is the closed type impeller, and there is the open type impeller. So in this, you see, this is the eye of the impeller. In this, if water enters at the center of the pump, and this water will pass through, this is the closed, you can say, closed conduit, circular closed conduit. So in this, water will come outside through these holes. You can see. So whatsoever water is coming here, and that will, because it is in the rotational motion, so that water will get the energy, and it will, with the help of this rotation of this impeller, and it will come out through these holes. This is the system. And what happens in this, similarly, you can say here that whatsoever is water coming here, it will going out through these guided veins are there. So this is the open impellers. So generally it depends upon the quality of the water. if quality of water is very good, it do not have the turbidity, do not have the sand, mud and other things. So we prefer to use the closed impeller for the higher efficiency in comparison to the this open impeller. And open impellers are generally used for the poor quality water having the more sand, muds and all those things. Because if you use the for poor quality water or muddy condition or sand condition in this impeller, there will be more wear and tear, and there is a chance because of the path or flow of water in the closed impeller is very narrow. So there is a chance for the choking of any foreign particles or any sand silt clay part sand silt particle, bigger gravel or anything. So to avoid that, we are using the closed open impeller under the poor water quality condition. So here you can see again that this is the closed impeller, semi-open impeller and open impeller. So now if you see, I told that there are two important components of this pump. One is the impeller and another is the casing. So now we will see what are there are two types of casings are coming which is surrounding the impeller. So now we will see those two types of casings. So here you can see those casings are there. One is the volute type casing and another is the diffuser type casing. So in the volute type centrifugal pump, impeller is surrounded by the spiral casing. I will show you, and outer boundary which is curved is called volute, and this absolute velocity of fluid leaving the impeller is reduces in the volute casing. So just we will you see this volute casing. So in the volute casing, this white portion is the impeller. In the impeller, these are the at the eye of impeller in which inlet or water will be sucked. So here you see the casing, the space between impeller and casing. At this point, space between impeller and casing is lower. Yes. Here the space between impeller and casing is lower, and if you go ahead, this is the direction of the motion of the impeller. So if it will go ahead, what happens? This space increases. Try to understand. So what happens if space increases? The scenario will be, what scenario will be generated? That because peripheral velocity of impeller, this impeller is a single commodity or single body. So peripheral velocity of impeller at every point will be same. So what happens? It means water which is coming out of the impeller is same, you can say, from the all the directions. Okay. Now what will be the scenario about the velocity of water? So if this water, try to understand here what happens from this place to this place, that we will see, and what is happening from at the eye of impeller to the periphery of the impeller. Try to understand. So if you see the cross-sectional area at the eye of impeller is lower in comparison to the cross-sectional area at the periphery of the impeller, and the quantum of water is sucked or quantity of water is passing through the pump will be same, you can say. So if it is same means Q, let's say a particular discharge Q at the eye of impeller, so discharge at the periphery of impeller will also be Q, means there will be a similar discharge. number one. Number two, if cross-sectional area is here lower and here cross-sectional area is higher, so what you think? Here there will be at the eye of impeller, velocity of water or velocity of fluid is very high and it is reduces with the passage of the distance to the surrounding. When it will go to the peripheral way. So velocity is very high. So what happens? If very high velocity is there, so, and if you that very high velocity, if it will get the power of the rotation, then it will come out periphery of the impeller, and what happens? Then that same amount of water, if it is coming to this side, here cross-sectional area is lower. So again the velocity will be very high, and again if this water is passes in the surrounding of impeller, the area, cross-sectional area is increasing. So what happens? Means velocity head of water is decreases starting from this point. If it will come down here and it will go to the delivery line, so velocity of water starts decreasing. Okay. So what happens? Means kinetic energy is converted from kinetic energy converted to the potential energy. So that's why this this water which is coming from this place is coming to the delivery line with less velocity, but it can be lift to the higher elevation. Its potential energy is increases, so that's why we can lift it to the higher elevation with the conversion of the velocity head into the pressure head. So this is the single stage pump, generally volute type of casing we are using. In single stage pump means there is no interconnected, you can say, connection of the impellers are there, that one impeller will supply water to the another impeller and another impeller will supply water to next impeller. Such type of scenario if not there, only one impeller is sufficient to give the desired discharge. Under that condition, we are generally preferring the volute casing of the pump. But second type of casing is the diffuser type of casing. This is the diffuser type of pump, you can say. So in this diffuser pump, impeller is surrounded by a series of stationary guide vanes mounted on the diffuser rings. Means try to understand here, this diffuser pump is like this. This is the casing of the diffuser pump. So just 1 minute, I will take little water. Okay. So again, I am audible, na? There is no any issue.
Yes, sir. Fine, sir. Fine.
Okay, okay. So if you see this diffuser type of pump, earlier pump you in this type of volute type of casing, you have seen the area surrounding the impeller is increasing, or you can say it has the variable cross-sectional area. So there is a more area at the starting, and at the delivery side the area is increasing, you can say. This type of scenario are there. But here you see in the diffuser type, this is the impeller, white portion is the impeller, But area, you see, area surrounding the impeller at the all the sides are same generally. There is no change in the area. So what happens? What is the scenario? That this again water will enter at the eye of the impeller and this will go to the outside. So what happens? This, if it is going to the outside, so there are these are the diffuser veins are there. This black these veins are there, and these veins are made in the casing of the centrifugal pump. So these veins in the casing guides the water to go water which is coming out of the impeller through the guidance of this diffuser veins. This water is going to the periphery. And because of the periphery, here there is a guidance is there in this direction. So what happens? This water will go to the periphery and it will adopt the path of the low pressure. Here you can say because of the guidance of the vein, then this water will try to from all the sides, water will try to go through these diffuser veins into the discharge side. And generally, we are using much such type of diffuser casings in case of the multi-stage pumps. Multi-stage pumps means you can say that the one impeller is supplying, as I told earlier, that one impeller is supplying water to the another impeller, means water which is going out, it will not, you can say, used here. This water will go to the delivery line is, let's say it is blocked, and the back of this impeller, if there is a another impeller, so for that impeller, this will be water which is going out, it will be the inlet of for that impeller. So that will be the multi-stage of the pump. We are using the impellers in series, so it will be better to utilize this type of casings. Now, if you in this way, if you take the pumps, you can say in series. So let's say here there is a pump P1 and this is the pump. If you connect it in the series, so try to understand what will be the scenario. This water will go to this pump and this water from here, it will work as a suction for this water and this is will be the delivery line. So try to understand what will be the scenario will be generated. So whatsoever the discharge Q will be there here, let's say that, let's say Q1 is the discharge here. Same discharge will come to the suction for this pump. So this will be the Q2. And if this is the Q, so you can say that Q1 will be equal to Q2 and Q. So this is also, you can say, on the basis of this diagram, that one pump provide the head up to this and this will be the discharge. But if you add another pump in the series, the head will be increased from this place to this place, means there is a enhancement in the head, but discharge will be same. So here you can say H head will be H1 plus H2. So that's why head with the connection in the series of the centrifugal pump, we can increase the head required or head for the delivery side or suction side. In this way we can increase, but we cannot increase the discharge. So discharge will be the same. So similarly, if you go for the pumps in the parallel segment, so here let's say this is the one pump, this is another pump, and it is giving the discharge. Let's say this discharge Q1 is coming, and here from another pump discharge Q2 is coming. So this here from both the pump water is coming and it is joining to a single pipe. So what happens? Because of the single pipe, so scenario will be that we require more larger diameter pipe because the Q will be Q1 plus Q2. Means we can get higher discharge. So you can see from this figure that one pump give the discharge, let's say Q1, and this another pump gives the Q2. So the total discharge will be Q1 plus Q2. So this is the Q condition. So in this way, but what about the head? Head will be what is the head developed by this pump and head developed by this pump will be the same. That's why the head equal to head H1 plus H1 equal to H2 equal to H means it will be the same head. We require more discharge but less head condition. You can say similar head condition. And then we can make the joining of these pumps in the parallel way. And this is the just I want to introduce what are the different part essential required for the operation of the pump. So as I told, this is the casing of the pump. In this there is a impeller, and this impeller will be in the connected to the prime mover, and impeller will be in the operating position. Means it will start rotating. So if it will start rotating, so at the eye of the impeller at the center, what happens? As you know that the in the delivery line here pressure is 1 atmospheric pressure. Here pressure is generally 1 atmospheric pressure. So what happens if in the eye of impeller, because of the rotation at the very high speed of the rotation, so what happens that the pressure in the eye of impeller is, or you can say, low pressure zone is created, because whatsoever things are coming, though air is coming or anything is coming at the eye of impeller, it is going to the outward direction due to centrifugal force. So what happens at the center of the impeller, there will be low pressure zone. Up to a certain extent you can reduce the pressure, or you can create the vacuum pressure up to a certain extent. You cannot create a complete vacuum of a very high level vacuum. That's why there is a, for the operation of this centrifugal pump, it is required to go for the priming. There is a terminology for priming of the centrifugal pump. So in the priming, what we are doing, we are filling the water in the casing, and so that casing will be full of water, and in the suction line also there will be water, because we are providing here the foot valve. So here there is a valve that one directional flow will be occurred. If water will be there in the suction line, that water will not go inside in the down because closing of the valve. So what happens in this section, if there will be water will be filled, you know that vacuum pressure general formula for P is rho GH. Try to understand, if the value of rho will be higher, you can create more pressure. Similarly, if you want to create the vacuum pressure and value of rho or density of fluid will be higher, you can create more amount of vacuum pressure or lower pressure in lower absolute pressure, you can say, in comparison to the, if here there is a air. So because the density of air is low in comparison to the density of water, and that's why generally for the priming we are using the water. So if rho will be high, so what happens? P will be high. So if P will be high, means more amount of high level of vacuum you can create inside at the eye of the impeller. If vacuum will be created in the eye of impeller and here water in the suction line is at 1 atmospheric pressure, then what will be the scenario? That automatically, because of the low pressure zone is created here, this water will go inside the at the eye of the impeller, and this valve will be in the open condition because this is the unidirectional valve, so it will be in the open condition and water will come here, and again that process will start as I told earlier, that the operation of the in the casing pump impeller will rotate and water will go into the delivery line. So such type of scenario will be started. So here at the starting of pump, that's why priming is done to create the high level of vacuum so that the starting of flow will be occurred. And here one thing, as I told, that the foot valve and strainer is used because to make that so that good quality water will enter into the suction line. This is the suction line below the eye of impeller and where water is there, and this is the delivery line which is giving water to the tank from the eye of impeller. So in this way water goes, and these are the suction flange, means the suction line will join with the pump with the flange so that there will not be any leakage of air. So because if there will be leakage of the air, you can understand, because air is at 1 atmospheric pressure and here vacuum you are going to create, so air is lighter, so instead of coming of water from this place, air will suck here. So that's why in the suction line always our motto is there that we have to keep the eye that in the maintenance part, that there will not be any leakage in the suction line. If delivery line there is a leakage, there will be no problem in the operation of the pump. But in suction line, there should not be any leakage or any air entry should not allowed, so that their pump will operate smoothly. Otherwise, it will not lift the water. Okay. So this is the principle of work, power, energy, and in this, you know that this is the net suction head, in which this is the because this is the water level, this is the net suction head, and in the suction line there is a flow of water, so there will be some, you know, that the if water is flowing in the pipe there is some frictional head loss. So that's why this is the suction friction head and suction velocity head, means water will enter with some velocity, so definitely velocity head will be there. So up to this you can say this is the suction velocity head. So these two in total it is called suctional resistance, and this is the static head from which water is lifted from this place to the this elevation. Water is lifted from this elevation to this elevation, so it is called the static suction head, and this is the eye of impeller. From this place to the delivery side, it is called the net discharge head. That the this is the net discharge head, and in the discharge line again there is a resistance due to the flow in the frictional resistance, so we can go for the delivery frictional resistance, and delivery water will come out with some velocity, so it has the delivery velocity head. So in combine it will be called as a discharge resistance. So in this way gross pumping head we can calculate for the pump. So this gross pumping head means this is the, if you are going to go for the efficiency of the pump and other those things, so this gross pumping head is required. Now, this is the static head. As I told you earlier, that this will be the suction head plus delivery head plus this H is come here for the total head, suction head plus delivery head plus frictional resistance in suction head, delivery head, and what is the velocity head is created. Then we have the manometric head, and this is called the difference in piezometric head between a point on the discharge side and a point on the suction side of the impeller, both as close to the pump as possible, is called the manometric head. Then we have the manometric efficiency. In this manometric head divided by theoretical head, so that is called the manometric efficiency. These are the indexes. Then we go for the net positive suction head. This is the important. This is the suction head at the eye of the impeller, because this if this net positive suction head will not be there, water cannot be lifted. So that's why we are much important point this NPSH. So this much suction head must be created by the impeller so that liquid is lifted up and sumped into the impeller through the suction pipe. So this is the NPSH is required, and the value of NPSH is absolute pressure head at the inlet of pump minus the vapor pressure head in the liquid of being pump and velocity head in the suction line. So that's why the formula is this, and in this way, using these formulas, and we can calculate the NPSH, and the cavitation in the pump we can calculate on the basis of these formulas, and PS by gamma, and this is the just numerical portion. I will not go much here. So in the specific speed is used for the comparison of the pump, to comparison of the two centrifugal pumps. So in this this is called the speed of a pump that is used, that what is the speed of pump under unit discharge and unit head condition. So if speed is different, then we can compare one pump to another pump on the basis of the specific speed. And then there is a pump law, because in the pump, as I told you, there is a impeller and it has the diameter, and then there will be a discharge, and this discharge and diameter scenario with respect to different speed and head and what is the power requirement. So with this, what is the relationship has been developed, this is called the pump law. So on the basis of that, you can say that if any one is known and the unknown, you can calculate or you can use for the comparison of the pump. And this is the minimum pressure difference you can calculate on the basis of the radial speed, and this is the priming. Then we come to the specific priming. As I told, that the operation in the suction line, we are putting the water so that it can raise the with the help of liquid raised by the pump before starting of the pump. So, and now important aspect is the characteristics curve of the centrifugal pump. In this, generally three parameters: head, power required, and efficiency, we take with respect to the discharge from the pump. So you can see from this graph that the, if try to understand, the discharge portion is in this direction. Try to understand. So if it is in this direction, so quantity of discharge is increasing. Try to understand for a particular RPM. So if head is, you are getting the discharge at particular head, so discharge at the starting position, discharge will also increase and head will also increase. Try to understand. But after certain level, after that, at particular RPM, if you increase the discharge, your head will start decreasing. This manometric head will start decreasing. So this is the nature of the graph. Means up to a certain stage, discharge is increasing, but if you again increase the discharge, your manometric head will start decreasing. So this is the one characteristics. Another characteristics is that if, let's say, this is a pump RPM and discharge and input power. Try to understand, you know that the very simple concept is there. If you want more discharge, P equal to gamma QH. So in this, if very linear relationship you can say is there, if you increase the discharge, input power will be more. Try to understand. In particular RPM, if you test the pump, increase the discharge, your power requirement will be more. So similarly, if you come to the overall efficiency of the pump, so overall efficiency of the pump will also increase with the increase of the discharge. If you see at a particular RPM, after that, then there is a decrease in the efficiency. Means it will increases up to a certain discharge. After that, efficiency starts decreasing. So this is the scenario of in case of the centrifugal pump. So means you cannot say that if you increase the discharge, efficiency will again increase. It will increase up to a certain discharge. After that, you can say this is the discharge line. After that, the efficiency of the pump will start decreasing. So that's why this graph, combination of these graphs, characteristics curve, is utilized for the selection of, you can say, at what is the optimum condition on which you have to operate the pump to get the maximum benefit from the pump. So here this is the Q, and here we have the different things regarding, let's say, head. At a particular RPM it has been there. So at particular RPM we are getting this head and discharge relationship. Then this is the graph for the efficiency. Then this is the power. So if you see this, so because of this zone, so this point you can select that if pump will operate up to for this discharge rate, and this will be the efficiency and this will be the head, you can say this head and discharge. So pump will give the maximum benefit or optimum efficiency will be there. So this is the recommended, in this way we can recommend that what will be the, to get the maximum efficiency, what will be the head and discharge combination we can utilize for a centrifugal pump. So thank you for providing me the opportunity. Now, if you have anything, you can ask. I have no problem.
Thanks a lot for this wonderful session. I think many participants has written their queries in the chat box.
Okay, how I can just I will see this.
Chat box, sir. So Mr. Deepak Nayak has asked question, what is semi-open impeller?
Semi-open impeller.
Yeah.
Yes.
Sir, you can see also, sir, chat box. So many questions are there.
Okay, 1 minute.
If possible. Otherwise, I will read for you.
No, just I will see. Now open. Okay, one by one. Sir, what is the semi-open impeller? So you just, I think, this slide is visible? No. Actually, impellers, there are two rows are there. in between there is a space. So this is the closed impeller. And if one side there is a boundary and other side it is open, there is no closed conduit is there. So that is the semi, that is the open. And in this, try to see this figure. I think it is visible or not? Sunny?
Visible, sir.
Okay, so this is the, you can see this figure. This is the semi-open impeller, means neither, this is the fully open, but here one side boundary is there and one vanes are there, guiding vanes are there. But here no boundary is there, both side open it is there, only guiding vanes are there, which are rotating. And this Deepak, and thank you. And sir, please, what happens if impeller size or diameter is reduced? So impeller size or diameter is reduced. So I told you that this FNT law is there, pump law. You can utilize this, and if D will increase, Q will, what will be the Q will increase. If D will increase, H will increase. So pump P will be there. So this is the relationship you can utilize. With the help of this, you can say whether what will be the scenario. What happens when centrifugal pump rotate in reverse direction? Very good question. So reverse direction, what happens? Try to understand. You can see here in case of the volute casing and this diffuser type of casing. So if try to understand that here rotation is going in, this is the direction of the rotation. If it is going in this direction, so what I told that the high velocity to uh, uh, will be converted to the pressure head. So means velocity head converted to the pressure head. So under this volute type of casing, this type of scenario will not, you will not able to generate. There will be the reverse direction. So you can say pump will not be the in operating position. It will not give the water. I think there is no more question.
Yes, sir. Yes, sir. I think there is no more questions, sir. Uh,
Okay.
I request all participants kindly fill the feedback link. Once again, I am sharing in the chat box to avail the certificate.
Okay.
Party sir, thanks a lot for your
Thank you.
valuable time, sir.
Thank you.
Thank you so
Thank
much,
you.
sir.
Earlier you have requested, I was could not able to devote the time, but today I am very happy that I obeyed what you have told. So thank
Thank you
you
so
to
much,
the
sir, for this
authorities and
wonderful
the Sunny
session.
of the KL
Yes,
University
yes.
for providing me the opportunity. Thank you one and all.
Thanks a lot, sir. Have a
Thank you.
nice day, sir.
Thank you. Thank you.
Thank you, sir.